Good day to all. I am Jonas Gigi Canosa.
I am Christian Edward Reyes.
And I'm Sofia Maria Mabaracoso. Our study is entitled Preparation and Electrochemical Characterization of Pectin with Sodium Nitrate as Biopolymer Electrolyte material for Supercapacitors.
For the problem, electrolytes are usually liquid-based and is the most common electrolyte used in supercapacitors. Liquid electrolytes, on the other hand, are prone to leakage and have poor chemical stabilities. Although solid electrolytes are used in supercapacitors, they are not biodegradable. Polymer electrolyte attracted the attention of the researchers because of its safety as an electrolyte used in electrochemical devices such as batteries and supercapacitors. The piece conductivity is quite low, and an additive that conducts electricity must be added to improve its conductivity.
Moving on to the variables. Pectin. Pectin is a heteropolysaccharide and is commonly used as an alternative biopolymer in the development of batteries. It is non-toxic, renewable, water-soluble, and biodegradable, making the researchers use it for electrochemical applications. Pectin, when mixed with electrolyte, produces a biopolymer electrolyte which can be used to electrochemical devices. Next is sodium nitrate. It is an inorganic nitrate salt of an alkali metal. It is crystalline solid which is white, and when dissolved in water, sodium nitrate dissociates into sodium ion and nitrate, making it a strong electrolyte.
Let us now move on to the methodology section. First will be the collection of materials. The pectin and the sodium nitrate, which is the main variable, were bought at DKL Laboratory in Spanish Street, Sampaloc, Metro Manila. Next will be the preparation of the supercapacitor. First part will be the preparation of the solutions, and under this is the solution casting method. The biopolymer electrolyte was prepared with a ratio of 25 pectin is to 75 distilled water, and 75 pectin is to 25 sodium nitrate. Next solution was the activated carbon paste. The activated charcoal with a measure of 17 mg was added into the beaker for the solution of the conducting paste. The washing up liquid was also added in a different beaker with a measure of 20 ml. Salt water was also made with a measure of 400 ml of water and 29.22 grams of salt. Droplets of washing up liquid and salt water were added into the activated charcoal. It is stirred at the room temperature to get the consistency of the paste. After the preparation of the solutions, we can now move on to the fabrication of the supercapacitors. The sample supercapacitors were made using a layering method. There are 4 different supercapacitors of samples made. The first supercapacitor is activated carbon only, which is the sample A. The second sample is activated carbon layered up with pectin, which is the sample B. Third sample is activated carbon layered with sodium nitrate, which is the sample C. The last sample is activated carbon layered with pectin with sodium nitrate solution, which is the sample D.
After the sample capacitors were made, we can now move on to the characterization. The first test is voltage capacitance test. The samples made was charged using a 9 volts battery. Samples A, B, C, and D were charged with different charging times. All the sample supercapacitors were charged for a minimum of 15 seconds. The time was increased to test if the voltage stored in the supercapacitor increased. The stored voltage was evaluated using a multimeter to determine the amount of voltage stored in the supercapacitor. 3 trials were done with 2.5 direct current voltage or DCV. The range used was 250 range and the results were divided by 100 to identify the stored voltage in samples A, B, C, and D. The second test is the electric conductivity test. The samples prepared were charged using a 9 volts battery. The samples A, B, C, and D were charged simultaneously at a minimum charging time of 60 seconds. The electrical current the samples carry was evaluated using an electric lamp in series with open electrodes to determine the amount of electric current the samples contain. For the last characterization test, electrochemical test is performed. The samples were prepared with a ratio of 80:20, wherein the weight of pectin, sodium nitrate, and sodium nitrate with pectin is 0.80 grams and the weight of the activated carbon is 0.20 grams. All the samples were diffused in their metal sulfoxide, then mixed to obtain a homogeneous mixtures. The mixtures were layered in a foil. All the samples were charged using a 9 volts battery with different charging times. These 3 sets of trials are set in order to make comparison with the samples. For the first, second, and third trial, Their 15, 30, and 45 seconds charging time are being sent to the samples accordingly. The test trials were executed by using a multimeter electronic device and finding the area exposed on the sample to test the sample's voltage after the samples were charged with different charging times. The stored voltage is used as the basis in which charging time is more effective to increase the storing of energy to the samples, as well to know if it is possible to use as supercapacitors.
For the results and discussion, Table 1 shows the voltage reading results of sample A, sample B, sample C, and sample D, which is tested using the multimeter. In sample A, the average stored voltage is 0.25 volts. In B, it's 0.50 volts. In C, it's 0.30 volts. And in D, it's 0.55 volts. Based on the results in sample D, which contains activated carbon and pectin, with sodium nitrate, exhibit the highest stored voltage. This result shows how PSN increases stored voltage of supercapacitor with AC as the electrode. However, sample A shows relatively lower results than samples B and C. This implies that the PSN as an electrolyte allows more voltage to be stored.
In conclusion, we were still able to fabricate an electrolyte from pectin and sodium nitrate and determine whether the electrolyte could be used to create a supercapacitor. Using the multimeter test, we were able to determine the voltage of the pectin with sodium nitrate. This study found out that the use of the pectin and the sodium nitrate as a solution for the biopolymer electrolyte allows more voltage to be stored. Again, representing Manuel G. Arroyo High School, we are the Innovation Group. Thank you and have a good day.